Hi everyone, this is Santiago from ctfframework.com, and we're going to be discussing model collapse, also called Habsburg AI, or how I like to call it, the cures of training AI on synthetic data. And first, a simple definition. So model collapse is what happens when we train AI models on data that was already generated by an AI, instead of using real human data. It's a decay process. Think of it this way. So AI models are statistical copycats. They love common patterns, but they struggle with rare, unique examples, what we call the tails of the data distribution. When model trains on its own outputs over and over, it starts throwing away these rare edge cases. Eventually, the AI outputs become incredibly repetitive and boring. It loses all its nuance, diversity, and ultimately its accuracy. It essentially forgets the richness of the real world. Why is called Habsburg AI? Well, the Habsburg dynasty in Europe kept intermarrying for generations to keep their power, which eventually led to severe health issues and the end of their family line. Researchers use this to describe intellectual inbreeding in AI. If we feed a model its own generated data, instead of fresh human data, it's exactly the same thing. So we are feeding its own mistakes, and every tiny bias, error, or hallucination in one model is treated as absolute truth by the next model. And these mistakes compound and build up until the AI completely breaks down. Okay, so the cures of recursion, and let's go through how this collapse actually happens step by step. So first, at stage 1, we train a base model, let's call it M0, on clean, high-quality human data. This is our gold standard. But then at stage 2, people start using this model and publishing its outputs all over the internet, polluting public data. Stage 3, we scrape the web to train a new model, M1, but we accidentally ingest the synthetic data. In stage 4, because the AI is learning from approximations, it starts forgetting the rare features, the tails of the data. And finally, by stage 5, after several rounds of this, the model collapses completely. It starts outputting repetitive loops, nonsense or gibberish, and it becomes useless. Okay, this is a visualization of that loop. So the diagram shows what researchers call the autophagus or self-eating loop. And I want to highlight two things here. So first, notice the real human data only enters at the very beginning, so feeding the model M0. After that, we are completely off the grid. Model M1 is trained on S1, which goes from M0, sorry, and model N is trained on S2, which comes from M1. And look at the red box at the end. So as we move down the chain, the connection to human reality gets weaker and weaker. Each generation dilutes the original data until we hit total collapse. So why should we care about this as tech leaders? So there are a few major business and technical implications here. So first, knowing the origin or the provenance of our data is now a top priority. So we have to make sure that our training pipelines aren't polluted by synthetic trash. And we need to realize that human data is finite and scarce. So second, training on synthetic data actually multiplies hallucination and biases. So it doesn't just make the model slightly worse, it compounds errors exponentially. And the big takeaway for our strategy is this. So we cannot build a business mode on generic web scrapes anymore. So our true value lies in securing proprietary and real world human data, like customer logs, real transactions, and our own human written code. So how to prevent model collapse? We have 4 main tools at our disposal. So first, we need strict filtering. So we must build classifiers to detect and weed out AI generated content before training. Second, we use data anchoring. So meaning we always mix our original human generated golden copy into every new training run. Third, we keep humans in the loop. Like techniques like reinforcement learning from human feedback, help align the model with actual human preferences, and keep it grounded in reality. And finally, we should support watermarking standards like C2PA. Labeling AI-generated media helps the entire tech ecosystem tell the difference between human and AI content. Okay, now to wrap up, here are the key takeaways you should remember. First, think of human data as the fossil fuel of the AI age. It is incredibly valuable, it is finite, and it is getting harder to find. AI models cannot run on their own exhaust forever. Second, recursive training without human grounding leads to decay, and this is a statistical fact. And your action items as a leader are secure your data pipelines, verify where your data comes from, and invest heavily in human validation. This is how you build a lasting AI advantage. Thank you for watching. Until the next one. Bye-bye.